Now attack this problem. See, this body, as you know, this cylinder has to be lifted over the step. Now, one thing is, you just have to ensure that this body just gets lifted. Understand? When you apply force. Yes. See, now you try doing it in the home. You will just apply force. Once you apply force and once it starts getting lifted, okay, the assumption here is that the body just lifts and starts and then gets onto the step. Okay, so you must not calculate any acceleration and all. So for all practical purpose, the velocity of that will not change. Yes. Hardly it will change. See, when you try to lift a huge thing like that, hardly it will change. With that condition, you must take. Don't try to calculate any alpha and all the things. You know? Do. Who told you not to do? See, this Arun is telling, sir, you don't do, I will do. Just draw the free body diagram. What are the forces acting? First, Arun, you are right. Aruna, sorry, and then say Yes. What is that? You got the same answer? Same answer?
Yes.
Very
Yes.
well. Two students. How many of you got the same answer?
Yes, sir. Yes, sir.
See, this mechanism, I hope all of you understand. Huh? See,
Yes,
you
sir.
have to just apply the force such that this should just get lifted over the earth.
Yes.
Just
Yes.
get lifted over the earth so that this normal force, what was there, this normal force sort of
Nice.
will become zero because the moment it is
Yes, sir,
lifted,
yes.
it is zero. And here the thing is, you have just made it to come up. That means you have created a small amount of, a small motion. You have created a small motion by just pulling it. And applying Newton's law here, this motion itself will propel it up. That's what is happening. It just moves, it just comes up. So you just have to calculate the equilibrium point. So what is the equilibrium? T. That is about this point P if you take here. This W into this distance.
Yes.
And F into this distance. This distance is very simple because this from here to here it is R and from here to here the unit is H. So this will be R minus H. Okay. And as far as this distance is concerned, this is R square minus this height. R square minus this height. If you take, then you will get 2RH minus H square. So F into this distance is equal to W into this. So therefore F is equal to square. Okay?
Yes. Yes, sir. Yes, sir.
Same answer?
Yes, sir.
Fine, good. Let's see what they have done. Okay. So you don't have to worry about any acceleration there. Same, we also got the same.
Yes.
Okay?
Yes, sir.
So therefore you see the diagrams and all look so complicated. Just don't worry. Just draw the vectors and draw it properly. You will get the answer. Okay? A bit of theory. This theory already I have dealt. So Newton's law for rigid body. So the FC means the net force on the center of mass will be m into the acceleration of the center of mass, and that's equal to d by dt of PC. And the same thing, its equivalent in rotational dynamics will be what? Okay, tau bar C will be equal to d by dt of LC, the rate of change of angular momentum. I have already discussed this. It is just that for the sake of syllabus, I am just touching this upon. And d by dt of t will be equal to d by dt of mVcm, and that is equal to mAcm. So FC is equal to mAcm, and d by dt dLc by this is d by dt of IC omega is equal to IC into alpha, tau c is equal to rotation. The above equations are Newton's laws of rigid equation particles. Take motion. That's it. I have already used this just because in the syllabus it has to be shown. I am just showing this. So rotational equivalent of this also I have dealt with it. Okay. So here L0, that is you are taking the angular momentum of a rigid body moving with translatory velocity Vc, okay, and rotating with omega. So its angular momentum will be Rc cross mVc bar. Already we have seen this equation. Body is translating and moving. Okay, so that equation we have written. And now if you Vc is equal to TRC, AC is equal to dVLC, alpha is equal to omega dt. This is known to us. Then if you differentiate this equation, then we are going to get Vc, this is d by dt of this one will give you what? D by dt of Rc cross mVc, okay, plus Rc into mac plus d by dt of Ic into d by dt of omega will give you alpha.
Yes.
Okay, right. Yes. And now here you can see Vc cross Vc. So this term will vanish.
Yes.
First term will vanish. So you will be left with only two more terms. Okay, what are the two terms? That is Rc cross mac bar plus Ic alpha bar. So dl by dt. So dLO by dt. What is this? This gives you tau bar. Okay, so tau bar will be equal to Rc mac Ic alpha.
Yes, sir.
We have already dealt with this also.
Yes, sir.
Earlier. So comparing the above equation, this is the rotation equivalent of Newton's laws of motion. That is Newton's
Yes, sir.
second law for rotational motion. You have to write it like this. This is the whole.
Yes, sir.
The above equation, though developed for plane motion, not only yet is valid for rotation about axis in rotation also. It states that the net torque about the origin of an inertial frame equals to the time rate in change in angular momentum about origin, and can be treated as parallel to Newton's second law, which states that no external force, net external force not equals time rate of change of linear rate.
Yes.
Okay. So this is the general procedure that we have to follow when we are solving these problems. Now here I have made this noting very important. So first, already we have used this in the problems now. In general, draw the FBD. In general, we have forces F and F2. Should show all the forces. Okay. And assume the linear acceleration of the center of body and angular acceleration. So Cm, ACM, and A omega and alpha. So these are the things. So resolution of forces, we flip the forces into two components. That is, you combine and split them into two. So you will get here Fx. Okay. So you can see here Fx is equal to m into ACx. Fy is equal to m into ACy. AC means the acceleration at the center of mass. And then writing the Newton's law for rotation. This is for translation for rotation. Tau c will be equal to summation Ri cross Fi bar. So Ic into alpha. Okay. So till now we have two force equations and one torque equation. So totally three equations, and we have three things. That is, see in all these problems you will have AC component along x, Ay component along z, and alpha. When the forces and the locations are given, we can frame the equations and solve to get the linear and angular accelerations independently.
Yes, yes.
Okay? Very simple. We have already used this. Alright. Now, solve this problem. Consider a round object having moment of inertia gamma m rc about its center, resting on a smooth horizontal surface. So there is no friction. A force F is applied as shown. Find the acceleration of the center of mass and the angular acceleration. Think properly and solve. What happens? Aram se think and solve. First understand what will happen, mechanism. Okay, can anybody tell me what will happen here?
Yes.
Hello, just please pause.
Yes.
What will happen? Yes, Arun, what will happen?
Sir, that lowermost points on the smooth surface will consider that as IC1 because acceleration of that point will be 0. So
Why acceleration at that point will be 0?
at that age,
Why?
Sir,
Have they told it is rolling without slipping?
say what?
Have they told it is rolling without slipping? Where is your mind? They have told it is smooth surface. Have they given any condition it is rolling without slipping? See, you should not live in this. You will not live with a lot of assumptions like that. That is a very. See, I'm telling you, this is a very bad habit for every human being. Humanly, I'm telling you. See, we should not unnecessarily assume something and start believing our assumption is correct. That's what I said. Caution. Read very carefully. This is physics. No word will be faltu here. And they are told resting on a horizontal surface, smooth horizontal surface. You catch that? No friction. So now force is applied. When force is applied, what will happen? First tell the mechanism. Apply physics and tell. Don't use intelligence.
Yes.
It will accelerate the center of mass. Yes.
It will accelerate the center of mass. To be more specific, you say, see, they are giving you x and y axis. So there will be some a suffix x. Ax will be there.
Yes. Yes.
What about ay? Ay will not be there.
No, sir. No,
Only ax will be there. Ay will not be there. What about alpha?
no.
Will there be alpha?
No, sir.
No alpha. What about others? No. You see, only because Om is telling it is not. May be true, may not be true. Will there be alpha or no? Will there be alpha or no? Angular acceleration or no? Okay. All of you are pausing. I will tell you. Now, friends, see. Hello. Are you with me?
Yes, sir. Yes. Yes, sir.
See, if the force vector is passing through the center of mass, then there will be only, then you have to consider only the translation mass or inertia of a translation. If the force vector is not passing through the center, see, that is what is the theory that I taught you. Then you have to consider the inertial rotational mass.
Okay, sir.
Okay, you have to consider the rotational mass. Correct? So now this force F can overcome the inertial mass and therefore will have translatory acceleration. Now this force F can also overcome the rotational inertia.
Yes, sir.
And therefore it should have alpha.
Yes, sir. Yes, sir.
Now whether it will roll or slip is secondary.
Yes.
See, my dear friend, no, ida tappu. Whether it will roll or slip is secondary. First, you understand that this body will have angular acceleration and also it will have translation acceleration.
Yes, sir. Yes,
Both it. Okay. So find acceleration of the center of mass and angular acceleration. They have asked you these two cases. That's all. So just do that. Now don't think about. See, it can slip. It can slide, or it can roll, or it can do both.
Yes, sir.
All the possibilities will be
Yes,
there. So don't worry about all those things. No, just do this. Find the acceleration of the center of mass. So they are given round object having moment of inertia gamma m r square. It's a round object. They have not told disk or anything.
Question.
Moment of inertia they have told.
See, one doubt. See, that radius is R, we should take it as R or what? Radius for that around object. But in that inertia equation, we found R square.
No, inertia they are told is gamma m r square.
Okay, sir.
So you take the radius as r and 2, otherwise you can't do.
Say radius R and 2.
Take the radius as r. Take the radius as r and do what else can I do? And take the mass as m. See, take the mass of the body as m and radius as r and I they have given you this. So take that and do. So this is r. So therefore this distance will be h minus r. So they are asking now ACM and alpha. So here, as we have already said, ACX will be equal to F by M. Okay, and ACY will be equal to 0. Then F into brackets H minus R will be equal to tau, and tau will be IC into alpha, and IC they have told is gamma m r square into alpha, and therefore alpha must be equal to F into brackets H minus R divided by gamma m r square. Did you get the same answer?
Sure, yes. H minus.
Hello?
Yes, I have.
Very simple, man. See,
Yes,
whatever the conditions are told, I have just put those conditions. That's all. They have not asked anything more. They have told it is smooth floor. So, no other questions. If they don't say smooth floor, then we have to think about this friction and we have to write the friction here, frictional force either this side or this side, and then we have to take that into consideration and do further things. Okay?
Yes.
Hello?
Yes, sir.
Yes. So we also got the same answer. Okay?
Yes. Alpha.
So you see, if h is equal to r, then alpha is equal to 0.
Yes.
Basic condition is passing through that. So no turning.
Yes.
Okay? Now you can take down this for homework. If the surface is rough, friction to prevent slipping, what is ACMX, ACMY, alpha and frictional force? Write down this question. And so tomorrow in the college, all of you can discuss. If you have time. Then what busy people. Yes, Murthy. Got it? Huh?
Yes.
Okay. So that's the homework.